The way we do math here in the United States, that's going to be more complicated for you to understand. And what we're really looking to help you understand is how to read the numbers on a meter. That's what we're focused on, how to read your meter face, what numbers mean on that meter. And so we're going to look at a whole number, and then we're going to look at the decimal equivalent of it. How is it written in a decimal form? And in scientific notation, we look at, if we come down here, we see on the other side of the decimal point, once we go into tenths, hundredths, 1,000ths of something, then the exponent becomes a negative instead of a positive. And we'll show you, that's important to understand when you're dealing with big numbers. But we're not going to be dealing with big numbers. We're talking about how do we read our meter. These are some numbers that you will see all on a meter when you're dealing with millivolts and milliamps and that type of thing. What do these numbers represent? Which one is the bigger number? That might be confusing to you, so we'll leave the exponents out of it for now. And let's just begin with that and look at the whole number. First of all, we know that in our system, our whole number system, we start out with 1 and then 10 and then 100 and 1,000 and 10,000. And what we're looking at is we're looking at points on the other side of the decimal point. If you look here, if you see you have the 1.0. Over here you would start with a tenth, a hundredth, 1,000th. But over here it's 1, 10, 100. And over here, as the number goes this way, it increases the amount of something. Over here, as you go this way, the number actually decreases. If I have 1,000th of an amp, that's not near as much as 1 amp. If I had a 1 right here and a 1 3 decimal points over, that would be much smaller than this one here. This just represents, or looks like a bigger number when it's written out, but it's actually a smaller amount. And over here, as it moves this way, the number increases in our number system. And that's what we see down here. And so when you interpret that in the power of 10, you see its equivalent exponent next to the 10. And this represents the amount of decimal points that are being moved. Okay, and the same over here. This negative number means the number of decimal points or times that you move over. That's what this number represents. Okay. Now for the novice do-it-yourselfers, I want you to take a good look at this chart. I want you to make a still photo of it. If you don't have this in your books or in your library, this might be hard for you to find somewhere. But since I have it drawn out for you, I want you to just take a good close look at this, because this will more closely explain what I was saying to you a minute ago. But it's laid out in a handy graph. We see here that this is the dividing point between the decimal between the milli, micro, nano on this side, or the percentages of 1, and then over here we start from 1 and we move over in the amounts each one's moving over times 10. Each decimal point you move over. So you see we have the 1 here in the units, we have the 10, and then we have the 100, and then once we move over 3 decimal points, we go into we would have a comma here in our number, and then we would be looking at kilo, and then when we move into this, or 6 zeros, and we would go into mega. And the mega, we see megabytes. This is the range we would be talking about in megabytes when you see it. And then you see giga, or the gigabytes. And now you're moving over into, this would be a million, this would be a billion. And if you keep going, you would have the terabytes now, which would be the trillion. And so on the other side, when you're looking at numbers that we have in the millivolt area, that would be the first 3 zeros on the side of the decimal point. So the first one would be 1/10, so that would be 1 millivolt. Then you would have 100th of a millivolt. Then you would have 1,000th of a millivolt. So if you see 0.0, if you have 0.0010 on your volts and you're reading millivolts, then you know that you would have 1,000th of a volt, and you know that that is a very small amount compared to 1/10 of a volt or a millivolt. But the milli falls in the first 3 points, or the first 3 zeros you would see on your DVM meter face. Okay, And then when you go into any number smaller than that, you're talking micro, and then nano, and then pico. And these are numbers you would be dealing with indeed in numbers dealing with high frequency type things, and you'll never see these on your on your scopes, I promise you. But anyway, the millivolt parts in our DVMs, when we're dealing with the numbers, this is what we want to consider. And so if you see 0.100, then that means you have 100 milliamps. If you see 0.01, that means you have a 100th of a milliamp, which if you have enough then you're getting close to a 1 millivolt. And you know, so that's what you need to consider when it takes 10 100ths or 10 100ths added together to come to 1/10 of a millivolt, and then 10 millivolts to add up to 1 volt. So let's just remember that. You know, you always have to think, what do I have to come to the next number? Okay? And this is how it goes out from that side. You need to write this down. Like I said, make sure you copy this down. And these are the numbers. This shows the numbers written out and how they would be explained if they were written out in their whole form. And again, here we see the numbers written out.